You are an administrator on the George Washington University School Board. Every year you are faced with choosing whether or not to cancel school because of impending weather. However, it is often difficult to determine how severe the future weather will be. Whether or not you have school can cause a variety of consequences, such as missed classes, dangerous driving conditions, unclear class schedules, and missed exams. Because of this, you decided to make a decision tree to decide when you should cancel school in order to minimize consequences. You have determined that you initially have three choices: to cancel school, keep school open, or look at the forecast. To keep these things simple, there are three possible forecasts: high, which would be 8 inches or above, medium, which is 2 to 8 inches, and low, which is 2 and under. Based on those forecasts, you can either cancel school or not cancel school. And also based on those forecasts, there are assigned probabilities on whether or not it'll actually snows enough to merit canceling school, which would be 5 inches. You have assigned a rating from 0 to 1 on how severe the consequences will be for each possible scenario.
Decision trees are made of decision nodes and chance nodes. Decision node, you pick the higher or lower value given the situation. In our case, we're picking the lower value to find the lowest risk. And chance nodes, you add the probabilities. In our decision tree, there are three options. You can either choose to cancel school based on the forecast, cancel school, or open school. In the case that you are considering the forecast, there are three possibilities. There is a high forecast, a medium forecast, or a low forecast. From there, you make the decision to cancel school or keep school open. And then there's the possibility that it's an exam day or a normal school day, and the possibility that it snows or that it doesn't snow.
After consulting the school board, you come up with a system of numbers between 0 and 1 that describes how bad it would be to cancel school or not cancel school given a different situation of whether it snows or not snows. If there's a high number, that means it would be very bad for the school, and if there's a low number, that means it wouldn't be as bad for the school in a given situation. For this problem, we were given that there are 14 weeks in a semester, and 3 of those weeks are exam weeks. We're also given the following probabilities: the probability that it snowed given a medium forecast, the probability that there was a high forecast and it snowed, the probability that it snowed given a low forecast, the probability of a low forecast, the probability of a medium forecast, and the probability that there's enough snow to cancel school. We need to solve for the probabilities that it's an exam day, the probability that it's a normal day, the probability of there being a high forecast, the probability that there's snow given a high forecast, and the probability that there is no snow.
If we're given how many weeks in the semester there are and how many weeks that we have exams during that semester, we can calculate the probability of there being an exam and the probability that there is not an exam. So just to calculate the probability of an exam, you take number of weeks, 3, divided by the weeks in the semester, 14, and you'll get 0.21. And for the probability that there's not an exam, you take 11 divided by 14, and you get 0.79. And if you just want to double check your work, you can do 1 minus either of these, and you'll get the other.
Given the probabilities of A, the probability of B, and the probability of A given B, one can solve for the probability of B given A using Bayes' theorem. Bayes' theorem looks like this.
So in order to calculate the probability of a high forecast, we assume that the probability of a high forecast plus the probability of a medium forecast plus the probability of a low forecast equals 1. So 1 minus probability of the medium forecast minus the probability of the low forecast is 0.2. Now in order to calculate the probability that it snows enough to cancel school given a high forecast, we use Bayes' theorem, which is the probability of a high forecast given that there was snow times the probability that there's enough snow to cancel school divided by the probability that there's a high forecast, which comes out to 0.6. Okay, so in order to find the probability that it snows enough to cancel school given a medium forecast, we know that the probability that it snows enough to cancel school given a medium forecast plus the probability that it snows enough to cancel school given a high forecast plus the probability that it snows enough to cancel school given a low forecast is equal to 1. So 1 minus the probability that it snows enough during a high forecast and the probability that it snows enough during a low forecast is equal to 0.3. And then to find the probability that it doesn't snow enough to cancel school, we do 1 minus the probability that it does snow enough to cancel school, which we know as a given is 0.35. So 1 minus 0.35 is 0.65. Okay, so to show a more in-depth way of how to actually calculate the decision tree, we copied the high variable from the larger decision tree, which we'll go back to in a second. But essentially, over here you have each of the risk or impact values for each of the scenarios, and then using these probabilities, so the probability that it snows enough to cancel school given a high forecast, the probability that it doesn't snow enough to cancel school given a high forecast, the probability that it's an exam day, and the probability that it's a normal day, you calculate these following values. So, whenever there is a chance node, you multiply each of the following impact values at the end by each of their probabilities. So in this case, it'd be 0.5 times 0.6, which is the probability that it snows enough to cancel school, given a high forecast, and then plus 0.7 times 0.4, which is the probability that it doesn't snow enough to cancel given school. And you apply this for all 4 of these values. Then you do the same thing again using 0.58 and 0.44. So 0.58 times by the probability that is an exam day, that's 0.21, plus 0.44 times the probability that it is not an exam day, which is 0.71. And you add those two up to get 0.43. And again, the same process applies down here to get 0.55. And finally, for decision nodes, we're going to choose the lowest value out of the 2 options that we have because that has the least impact on the school. So that's 0.43. So if there's ever a high forecast, the school should cancel school.
By applying the same equations used to solve for the high probability, we did the same thing for the medium and low probability as well as the cancel and open school probabilities to find the correct decision and chance nodes.
In order to solve a decision tree, you must work from the back of the tree where all of the impact values are, towards the front of the tree. Once you have solved for all of the weights, you make your decision starting at the beginning of the tree, and then follow the branches and their probabilities until the end.
At this decision node, we recommend to use forecasting as it has the lowest impact on the school's outcome. With forecasting, we then have it divided into high, medium, and low. At this decision node for the high forecasting, we would recommend to cancel school as it has a lower risk than for opening school. For medium forecasting, we would recommend to leave school open as the impact would be less on the school than if we were to cancel. In a low forecast, we would also recommend to leave the school open as it has a much lower impact on the school than to have the school closed.
This is our simplified and final decision tree displaying only those decisions that should have the lowest impact on the school in the long run.